Taken for granted. Did you ever think of the impact of that word? If something is taken for granted. A friend wants to borrow a car. There's no problem with that. You toss them the keys. And they walk outside and it's a standard transmission. And they've never used a standard transmission. But when you tossed the keys, you just took for granted they wanted to borrow a car. You didn't ask about if it had to be a standard or an automatic. So what do you do now? Teach them how to drive a stick? Give them a ride to where they need to go? So that's the nuance of taking something for granted, maybe. Trying to conceptualize what I'm speaking to. But this is important when you're speaking to the domains inside of science. If you're speaking to a physicist, if you're speaking to a nuclear chemist, if you're speaking to a radiological specialist, if you're speaking to an analytic chemist working in, say, forestry services, if you're working in a steel mill, with a bunch of people that have no idea what a computer is. Honestly, it was that stark depending on what building, what place you went into. So you tried to keep this in mind when having a conversation. The person you're trying to explain, say, a tape loader to, who has experience with loading paper tapes. So these little nuances, these little experiences through your life give you a lot of take for granteds that somebody else knows what they're saying. So one of these take for granteds out here that I go by, base reflectivity. If I was sitting in a room with radar professionals speaking about radar systems and how they work, this notion of base reflectivity is simply huge. Base reflectivity. So I'm talking about radar, and a radar signal, a high frequency EMF pulse striking an object 50 miles away and returning 1/10,000th of the signal that was sent out from the radar set. You get into details like signal to noise ratios, signal discrimination, and trying to pick a blip out of a very noisy background on an oscilloscope, for one example. Or maybe nowadays you have some advanced analytics to turn on against it. It sits there underneath running on a supercomputer somewhere, putting this information together. So that term base reflectivity is massive. If I was in an audio studio, now we're in an audio range, right? Voice, sound transmission through air, another discrete energy transmission process. It's energy, you're hearing energy transmitted through the air. Your ear is able to pick up very specific range of that. So base reflectivity, what would that have to do with your hearing, your voice, your sound? Base reflectivity to an audio engineer is going to be the echo in the room, the feedback in the room, the little bit of noise from all of the little fans running in different equipment maybe, or this microphone moving, rubbing up against something. Those nuanced are a base reflectivity conversation on how sound waves bounce off of things, are reflected or absorbed by things. So when you open that little word up and you take for granted that people have a basis for understanding, that phrase, base reflectivity, people have a basis for understanding what you're talking about. But to me, base reflectivity in optics would be pointing a laser to look through a window, and you get a reflection back from the window that you need to cancel out so you can see past that window. That's how you focus a camera. It's complicated. Don't make it simple. Too simple. Good morning, and peace is out.